Welcome to this video lecture on the subject Basic Electrical and Electronic Circuits. In this lecture, we are going to discuss about source transformation. So in circuit analysis, we use many network theorems and various circuit analysis techniques. So in this, we use source transformation in the case where we need to solve the complex circuit. So it is used to simplify the circuit analysis, and it also facilitates the nodal and mesh analysis methods. It is widely useful in network theorems like Thevenin and Norton's theorems. So what is the need for source transformation? It converts voltage source to current source and vice versa. What is meant by source transformation? So we convert the voltage source into an equivalent current source, or convert current source into an equivalent voltage source. So when we are changing the sources, we have to keep in mind that the external circuit should not change. So as shown in this diagrams, voltage source can be converted into current source. So V in series with R, it is converted to current source using the formula I is equal to V by R. So equivalent current source is connected in parallel with the resistance. And next is the conversion of current source to voltage source. So in the given circuit, current source I is connected in parallel with resistance R. So this circuit is converted to voltage source in series with R. So V is equal to I into R. So using this, voltage source is connected in series with resistance. Same value of resistance is used. And rules for source transformation. So this method is applicable only for practical sources. So external terminals and external circuit must behave identically. Power delivered to the load remains the same. And also it is used in nodal and mesh analysis. Comparison. So voltage source and current source. So when we convert from voltage source to current source, it is current is parallel with resistance, and the formula used is I is equal to V by R, and for voltage source V equal to I into R. Advantages of this method are it simplifies complex circuits, reduces the number of equations. So when we have more number of loops, so when we convert from current source to voltage source, we can reduce the number of equation. So because we use KCL or KVL when solving for the circuit analysis techniques. So we can reduce the number of equations using the source transformation method. And also when we are using the network theorems like Thevenin and Norton's theorem, we can reduce the complex circuit to simplified circuit. So when we have a more number of components, we can simplify the circuit using network theorems. And also it helps to choose easier analysis methods and useful in network theorems like Thevenin and Norton's. An example. So in the first diagram, 120 volt voltage source is connected in series with resistance 6 ohms. So this is converted to current source. So use the formula I is equal to V by R. So we get 20 ampere. So it is connected in parallel with 6 ohms resistance. And in the diagram C, 40 ampere current source is drawn in parallel with resistance 0.8 ohms. So to convert this current source to voltage source, so formula applied for this is V equal to I into R. So I is 40 amps, it is multiplied by resistance value 0.8, so we get 32 volt. So in the diagram D, the voltage source 32 volt is connected in series with 0.8 ohms. So in the first example, voltage source is converted into current source. In the second example, current source is converted to voltage source. And note down the polarities. So in the first polarity is denoted as plus minus, and current direction is according to it arrow mark. And in the second example, current direction is downward, so it is marked as polarity minus plus. So when we are solving the problems, we need to Check these polarities and current directions to avoid the errors. Assessment questions. If your 10 volt voltage source in series with 5 ohm resistor is transformed into a current source, what is the value of current source? So I is equal to V by R. So we divide 10 divided by 5. It is equal to 2. So 2 ampere, answer B is the correct answer. A voltage source connected in series with resistor can be converted into current source in parallel with resistor. So the answer is B. Thank you for listening this lecture.